This is a video for homework for number 6, and it's 10.2.7-T. So here we're supposed to test the hypothesis using the p-value approach. So the first thing we have to go ahead and check, and they're kind of guiding you through this here, since this is a hypothesis test for a proportion, that we have to check that n times p times 1 minus p is greater than or equal to 10. And this is kind of like when you had to check and verify if a distribution was normal in 5% of the population. So to do that, I would just use your calculator in Google. It's an easy way to do that. So the values that you're using here, again, we're doing n times p naught. That's how we kind of describe this here. And in this case, your p naught is going to be 73 divided by 125. So you actually have to find that first. So p naught is x over n. So I'm going to do that first just because it's easier. So 73 divided by 125. So 0.584 is my p naught. I'm multiplying that by n, which is 125. So times 125. And then I'm also multiplying that by 1 minus p naught. So you can actually use parentheses here. So I'll do 1 minus 0.584. And then I'm getting 30.360. So I say, okay, 30.368, is that actually greater than or equal to 10? And it is. So I say yes. And I can click there. Okay. The next thing we have to do is find our p-value. So there are two ways to test hypotheses. You can use the p-value approach, or you can use what they call the conventional or classical approach, which is using z-scores and a z-test statistic. But the p-value approach, I think, is probably easier. The whole idea is that once you say your alpha value, if p is low, meaning lower than alpha, you reject h naught. So if p is low, h naught must go. Okay, so that's how it kind of works. So we're going to do that by going into StatCrunch. So do question help and StatCrunch. And we're going to run our hypothesis test. So to do that, you're going to go to Stat. This is a proportion, so proportion stats. One sample with summary. Now we're given the summary, we're given the number of successes and the total in the sample. So our number of successes is 73. Our number of observations is 125. And notice here that actually they already had 0.5 written in. We just have to check that this is correct, and this is supposed to be a greater than in my problem. It might be different for yours. And click compute. So it looks like my p-value is going to be 0.0302. They want me to round to 3 decimal places. So 0 is in that third decimal place. There's a 2 next to it, so I'll keep it the same. So 0.030. And you do have to put that 0 in there if it's rounding to 3 decimal places, otherwise it will mark it wrong. So I'm getting that. And then we have to decide what to do here. So again, if p is low, the null must go. So is 0.03 less than alpha, which is 0.1? And yes, it is. So in my case here, and it may be different for you, but I'm going to reject the null hypothesis because the p-value is less than alpha. And I believe that's the end of my problem. So let me know if you have any more questions. I'd be happy to help.